Hello from me, Lazarus. Welcome to the next series of tutorials on Introduction to Lazarus IDE. Currently we are working on my third book. Here is the whole series. This is the first, the second, the third. I said, we are working on my third book, Introduction to Lazarus IDE Part III. It consists of two variants, Basic and Full, which besides the Basic includes also the real software system MyStore. Currently we examined first chapter, the previous two lessons, and second chapter, the component string list, and we continue with third chapter, the component tree view. Let's open the PDF file. And again we will divide this lesson into 2 or 3 parts, as one, the first, will be theoretical, and after that the practical example. And with this component we got acquainted in my first book. It represents a tree structure, which is created through double-clicking on the component. And we saw there also how to add beautiful small icons through TTreeView and how easily to save and read this tree in a simple text file, through buttons and the commands for working with a file, for opening and saving. If we make a simple program for home use, this is completely sufficient for working with this component, but in professional business programs, the categories of the goods are not entered manually in the designer of Lazarus, but are extracted directly from the database upon starting the program, and after that only are arranged automatically on the screen. But in this chapter we will not reach to this level, but we will deepen a little more our knowledge about this component, as we examine some more basic things. How to build the tree dynamically through code, and after that how to connect it with other components, to filter data and so on. So, the first point of the chapter is Anatomy of the tree. The class tree node. While StringGrid works with cells, StringList works with lines, strings. Then TreeView works with a completely different object, called node, tree node. All nodes are located in the collection TreeView.items, as each node has several very important properties, which connect it with the others. The first is parent, the node that stands one level above it. If it is empty, that is nil, has value nil, it means this node is at the top level, that is, this is the root element. It is called root, as in the hierarchy of HTML. We can imagine it in this way. Level shows how far inside is the node. 0, root, 1, first level, and first sub-level, and so on. Text, the caption itself, which the user sees on the screen, for example electronics. Also important is the following. When we work with such a tree, we always must check whether the node actually exists, before reading its text. Node.text. Programmatic building of the tree is the next point. When we write code, we have two main methods for adding nodes. We must understand the difference between them and be careful and take into account when to use which. These methods are the following: items.add parent text, adds a new node at the same level. As specifying a parent, that is as its brother or sister, so are called these brotherly or sisterly, which are at the same level. If we specify nil, there is created an entirely new main category. Items.addChild, again parent adds a new node one level lower in the tree, that is sublevel, as a child of the specified parent. In this way the subcategories are created. This is regarding the theoretical part of this lesson. In the next part we will examine a practical lesson, so you can see actually. Here is what represents this tree structure, which we are talking about, because here it was very theoretical. And, so you don't remain with unclear impressions, I am showing the structure. This is all for this lesson. Best regards.